So hi guys, I trust you're well. It's Prof here, and I'm just going to walk you through these few questions on complex numbers so that you just get a feel for what we're going to be asking, questioning, and almost bothering you. So hopefully the next few minutes will take you into an awesome journey into some really cool questions on complex numbers. So let's get started. First question, what is the imaginary part? Imaginary part, have a look, focus, focus. Imaginary part of Z1 times Z2 minus Z3 if these numbers are given as Z1 is 2 minus J, Z2 is 1 plus J, and Z3 is equal to 11 minus J2. Does it say 11 or 11? Okay, so let's have a look at that very carefully. You know that the imaginary part would basically be looking at the coefficient of J, but we're going to look for this combination over here. So let's work that out first before we look at the coefficient of J. So Z1 times Z2. Let's just try that separately. So Z1 times Z2. What is that equal to? You've got to be very careful when you multiply. These things can be tricky. And that is 1 plus J. Distributive law that you learned way back in grade, I don't know, 2 maybe? I don't know. So 2 times 1, that's 2. Then it's minus J plus 2J. That gives me J. And then minus J times J. Just be careful there. J times J is minus 1, and there's a minus sign, so that becomes plus 1. So we're going to end up with 3 plus J. Let's double check that. 2 times 1 is 2. There we go. Minus J and 2J becomes J, correct? Minus times plus, that's a minus J times J is minus 1, and then plus 1. 1 plus 2 is 3 plus J. Perfect. So we got the first part sorted out. Now we got to subtract minus 3. So we're going to go Z1 times Z2 minus Z3. So we know Z1 times Z2 is 3 plus J and minus. Now don't forget brackets. I keep emphasizing brackets. So that becomes 11 minus J2. So that becomes 3 minus 11. That used to be minus 8. And J minus, be careful here. J minus minus plus J2 becomes J3. And so the imaginary part of this number is just the coefficient. So the imaginary part of Z1 times Z2 minus Z3 is the coefficient of J, which is 3. Hoo-hoo! That's pretty awesome. Don't rush. Take it easy. Think as you ink. Whoa, what have we here? Man, this looks complex. 1 plus J to the power 8 times root 3 minus J to the power 6. 1 plus J root 3 to the power 12 times J. Oh my goodness. And it says simplify. So let's have a look at that. And I'm thinking here, if you look at this very carefully, I mean, you are not going to go 1 plus J into 1 plus J into 1 plus J into falling asleep there. So it's going to be an easier way of doing this. So let's have a look. How about converting each of these guys into what? Exponential form. So for example, 1 plus J. Let's call that Z1 is 1 plus J. If I had to plot that in the Argand diagram, 1 plus J, first quadrant, we know straight away. And what's the length of that vector? The modulus, Z1, the length of that vector is the root of 1 squared plus 1 becomes root 2. The angle there, theta, is pi by 4. Remember that. We know this. So we can write Z1 in exponential form as root 2 e to the j pi by 4. Agreed. Let's look at Z2. Let's call this guy Z2. So Z2 is root 3 minus j. Again, just use a little diagram to point out where this is. So root 3 minus j would be, remember this is the imaginary part over here, the real part over there. So root 3 would be 1.7 something out here and minus j down here. So that's in the fourth quadrant. Okay, so now we know it's the fourth quadrant. And now let's work at theta. So we know that tan of theta It's the imaginary part all over the real, so it's minus 1 over root 3. And so remember, we're going to work here with negative theta. But minus 1 over root 3, do you forget, you forgot, you forget? Let's just draw a little triangle. Special angles, by the way. So this is pi by 6. This is pi by 3, if you remember. 1, 2, root 3. So it tells me straight away tan of theta, 1 over root 3. That must be minus pi by 6. Please check that. Okay, that's awesome. So it tells me that Z2, this number, can now be written as, what's the length of that vector? Square root of root 3 squared, which is 3 plus 1, that's 4, that becomes 2. Haha! E to the minus j pi by 6, that's Z2. No need to rush, okay? Let's look at the next one. Let's call that Z3. So what is Z3 equal to? That is 1 plus j root 3. So we're going to go like that. J root 3, again, first quadrant, yeah, somewhere there. And so we know tan theta is going to be root 3 upon 1. Look at my diagram over here. That's pi by 3, so it tells me theta is opposite over adjacent, so theta would be pi by 3. So we know that Z3, watch this, what is the magnitude of this? Again, 1 squared plus root 3 squared. The square root of that becomes 2e to the j pi by 3. Are we good to go? Yes, we're almost good to go. Yeah, we got the j. I'll look at that just now. So 1 plus j to the power 8. There's it over here. Beautiful. E to the j pi by 4 raised to the power 8. Root 3 minus j, where's that? E to the minus j pi by 6 raised to the power 6. Are you following? And 1 plus j root 3, 2 e to the j pi by 3 raised to the power 12, right neatly. And j, haha, j, not this j. No. So that j would be pointing along here. So that will just be 1 e to the j pi by 2. That's the angle. And look what we've got here. Now we've gone back to like what? Grade 8. Just simplification using exponentials. And so this becomes root 2 to the power 8. The other one is 2 to the power 12. E to the j pi by 4 there would become e to the j pi times 2. 8 over 4 is 2. This is times 2 to the power 6. Lots of 2's. E to the minus j pi by 6 raised to the power 6 is e to the minus j pi. And the last one at the bottom here, just watch, e to the j pi by 3, that's 12. That becomes e to the j 4 pi. And the last one there is e to the j pi by 2. Now, I'm not going to finish this question. It's pretty obvious what's going to happen. You are going to simplify the constants. And then you got same base. What do you do with the indices? If you're multiplying, you add. And if you're dividing, you subtract. I'm running out of space here, but I can maybe use this mangoish color over here. Mangoish. That's a new word, I think. And let's see whether we can go. So what is root 2? That is just nothing more than 2 to the power 4. 2 to the power 4, that's 2 to the power 10. So that becomes 2 to the minus 2. Please check my calculations. And then you got e to the j. Watch this, e to the j. And what goes in the brackets? There's 2 there. There's 1 there. So it's 2 minus 1. I'm dividing, so it'll be minus 4 minus half. And all multiplying pi. 2 to the minus 2, that's just over 4. And let's see whether we can actually add some fractions. That's 2 minus 1 is 1. 1 minus 4 is minus 3. Minus 3 is minus 6 over 2. That becomes minus 7 over 2. So this is minus 7 over 2 pi. Please write neatly. This is a bad example. of writing. Okay, so please check that e to the minus j is 7 over 2 pi over 4. Just check my algebra here. I'm actually doing this while I'm skateboarding. Awesome. Aha, nice question. You got a z squared there, beautiful. And then you got z dot z bar, complex conjugate. The word conjugate, don't you think of conjugate acid-base pairs? Amazing. Okay, let's just have a look very quickly. Let's just do this by parts. So the first thing we'll look at is what is this thing called z squared if z is given by that. So let's treat this separately. So z squared we know is z times z, so that's 1 over root 2 minus j 1 over root 2 squared. If I square that, 1 over root 2 squared is a half. And then watch the center term. There's a minus sign, and 1 over root 2 times 1 over root 2 is half times 2 becomes minus j. Beautiful. And now watch. I'm going to square that. So 1 over root 2 squared is a half. J times j, and then you got a minus sign. So it's minus j. In fact, it's minus. I'm going to write this out for you so you can have a look. J 1 over root 2 squared. So that becomes a half minus j. Now j squared is minus 1, so that becomes plus, and that becomes 1 over 2. Agreed. So 1 over 2 plus 1 over 2 becomes 1 minus j. It's quite beautiful, it's simple, and it's interesting. And so now we're going to go with the bottom. What is z bar? Well, firstly, z bar you need to realize is 1 over root 2 plus j 1 over root 2. So if I go z bar, if you remember from our lectures, that is 1 over root 2 minus j 1 over root 2 into 1 over root 2 plus j 1 over root 2. It looks like the difference of two squares, but don't fall for that, because this is nothing more than the first term squared and plus the second term squared, which is 1, a real number. Agreed? Yes. So let's put all of that together. So that becomes z squared was 1 minus j. Oh, this is beautiful. Minus 1 minus that 1 all over 1. Look at that. 1 minus 1 cancels out. Over that becomes a minus j. So the real part of that number, z squared minus 1 all over z dot z bar, is actually equal to 0. Beautiful. All right, so something slightly different over here. Which quadrant is this combination z1 over z2 minus z2 bar if z1 is j and z2 is equal to 1 plus j? Let's have a quick look. So z1 is j, z2 is 1 plus j, so we know that z2 bar should be 1 minus j. Now, if you look at this very carefully, you've got z1 over z2 minus z2 bar. z1 is j, z2 is 1 plus j minus z2 bar. Watch the bracket, 1 minus j. So now we need to get rid of this guy. And the way we do this, you remember from class, is multiply by the complex conjugate top and bottom. Minus 1 minus j. So the top is j into 1 distributive law, j minus, now what? J times j is minus 1, so that becomes plus 1 there. Minus and minus becomes plus. 1 plus j into 1 minus j, hey. That is 1 squared plus 1 squared, which is 2. It's a real number. Minus into 1 minus j. So we want to now simplify that. Take a common denominator, put it 2 there. So then I've got 1 minus 2. Watch that. 1 minus 2 is minus 1. And j minus minus, that becomes plus 2j, so that becomes minus 1 plus 3j all over 2. So let's double check that. J minus times minus plus, that's 2j plus j gives you 3j. And then you got minus 2 plus 1 becomes minus 1. So now if I had to sketch this thing, which quadrant is that? Remember, this is the imaginary axis, this is the real axis. So if we're sketching this, it's got minus a half, would be somewhere there. and 3 over 2 somewhere up there. So without a doubt, this vector, this combination is in the second quadrant. So quadrant 2. Do you agree? Awesome. Aha, I was looking for this one. Z squared equal to 1 minus j. Solve for z. What values of z will make this equation true? Now this is very interesting. All right, you take the square root on both sides, you'd say, but hey, it doesn't work like that. You know, when you're looking at complex numbers, that becomes z equal to 1 minus j to the power half. But what do we mean by 1 minus j? Let's start over there. So I'm just going to repeat that, and I'm going to call 1 minus j. I'm just going to give it a name, a label. I'm going to call it 1p equal to 1 minus j. And then I'll ask myself, in which quadrant is 1 minus j sitting in? Remember, this is the imaginary, this is the real. Positive 1 minus j there, so it's sitting in the fourth quadrant. And then we ask ourselves, what is the angle? Remember, it's always associated with it. So this number p has length, the length of p. Think of it as a vector. Is root 2. And then we got tan theta is, well, obviously minus 1, imaginary over real. So theta is minus pi by 4. Right? Remember the principal values of z, yes, of p. But now think about this very carefully. This number p is not unique, because if we add 2 pi to minus pi by 4, we'll come back to the same point. Okay. So we can write p. Now watch this. This p can be written as root 2, that's its magnitude, e to the, now you got minus pi by 4. So this is how I like to write. Watch this. J minus pi by 4 plus 2k pi. Does that make sense? Because if we keep adding 2 pi to that, multiples of that, we're just going to come back to the same point. So that represents the same vector, so to speak, or phasor. So essentially what we're looking at, if you got z squared equals to p, that's the original question, then it tells me that z is p to the power half. But what is p? It's this guy. So of course, z is now equal to the square root of 2 to the power half at e to the j, watch this, minus pi by 4 plus 2k pi all over 2. That's it. So we have two solutions here. We're going to have k equal to 0. That's going to give me z1, which is root 2 to the power half. When k is 0, that's gone. So it's e to the minus j pi by 8, and that you can write as a polar form. And then the second solution would be k equals to 1. Again, this is going to tell me z2 is root 2 to the power half, but now it's 2k pi, which is 2 pi minus pi by 4, and then you're going to e to the j. So that's going to be 8 minus pi, 8 minus 1, that becomes 7 pi over 8, like that. So just double check that. Take a common denominator on top, that becomes 8, 8 minus 1, that becomes 7 pi, 7 pi over 4 divided by 2 becomes 7 pi over 8. And you can present this in polar form. Polar form, this will be nothing more than root 2 to the power half cos of pi by 8 minus cos of pi by 8, because there's a minus sign over there. This one will be root 2 to the power half into cos of 7 pi by 8 plus j sine of 7 pi by 8. Awesome. All right, previous question was z cubed equal to z squared. Now we're going to go z cubed. Same method. Method is important here, right? So let's have a look at that. And obviously, you know what I'm going to do. I'm going to let p equal to 2 plus j root 3. Let's establish which quadrant it is, the associated angle, as well as the length of that vector. So firstly, we're going to go P equals to, don't like that color there, 2 plus J root 3. Magnitude will be root of 2 squared, which is 4, plus root 3 squared is not 9. It's 3. So this becomes root 7. And now let's look at which quadrant this guy is lying in. It's lying in the 2, value of 2, root 3. So it's of course in the first quadrant. And so we're going to go tan theta is root 3 upon 2. So theta would be obviously tan inverse of root 3 upon 2. So now we know the angle, and then we go through the whole process and say, okay, now I can write down, watch, I can write down P. P is the magnitude, which is root 7 e to the j. Now watch, this is just one angle. And as I said, if we keep adding 360 or 2 pi, we're going to come back to that. So this becomes tan inverse of root 3 upon 2 plus 2k pi. Now I wrote this deliberately because I want you to realize that angle is in radians. And so if I want to solve this here, so I'll say z is eventually the cube root of p, which is then equal to root 7 to the power 1/3 e to the j tan inverse, which is now a number in radians, plus 2k pi all over 3. And then you generate your 3 solutions. Your 3 solutions would be k equal to 0. You'll have a z1 for that. Please write this out. K equal to 1. You'd have a z2 for that. And the last one is k equal to 2, and you'd have a z3 for that. And write that in polar form, and that's your answer. Poppity, 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 pop. Very straightforward. The P method, for me, works beautifully. Whoa, I love this question. De Moivre's theorem. De Moivre's theorem. Right, z equal to 3 into cos theta plus j sine theta, all cubed. Write down the real part of this number. Well, let's have a look at this carefully. The problem is the bottom here. But if you remember the theorem, what does the theorem state? The theorem says that cos theta plus j sine theta raised to the power n is cos n theta plus j sine n theta. So this can be written straight away as cos 3 theta plus j sine 3 theta. It's still not very good because we want the real part. So this becomes 3. It becomes cos 3 theta plus j sine of 3 theta. What do you do next? Of course, multiply by the conjugate. Cos 3 theta minus j sine 3 theta. Brackets, brackets, beautiful brackets. Minus j sine 3 theta. So what's happening on the top? So you're going to get 3 into cos 3 theta minus j sine 3 theta. Haha! Look at the bottom. Beautiful. Cos squared 3 theta plus sine squared 3 theta. And this is going to be 3 into cos 3 theta minus j sine 3 theta. And they want to know the real part of that number. So the real part of z is going to be 3 cos 3 theta. Agreed. Beautiful. 2020. Let's have a look at this. Same method, right? So you're going to go z equals to j into De Moivre's theorem, cos 20 theta plus j sine of sine with a double n 20 theta. And then I'm going to multiply it by cos of 2020 theta. It'll be confusing to say. Minus sine of 2020 theta, brackets all over cos. I should have used a square bracket, much better. The zeros and the thetas are confusing the hell out of me. So we know the bottom's going to be 1. The top's going to be j into, here comes my beautiful square bracket, 2020 theta minus j sine of 2020 theta. Look at that confusion all over 1. So they want the imaginary part. What's the imaginary part? So that tells me, let me write it up here. That tells me that the imaginary part of z, be careful now, it's the one which is the coefficient of j. So the imaginary part is j, so the coefficient is cos 2020. Cos. Lovely. What is the real part? Ha! Not minus. It's sine of 2020 theta. Beautiful question. Love it. Okay, so what is this, right? In rectangular form. Now remember, rectangular form, complex number, has to be written in the form z equals to a plus jb, where a and b are obviously real numbers. Now here you've got this ln 5/13. What does that mean? Well, think about that on the inside here. We've got the magnitude of the complex number, which is 5. And then we got 315 degrees. Now, you'd remember when we are chatting, when we were looking at principal values, we looked at theta lying between minus pi and pi. Sorry, strictly. And then less than pi. Okay, so that covers the entire 4 quadrants. So the 315 degrees, just have a look at that. Let's put things in the form of a picture or Argand diagram. 315 degrees, and if you went out that way, it would look there. That lies outside this requirement here. So the angle we're really referring to is minus pi by 4. So that's the first observation. Minus pi by 4. So what we do is we write this chappy on the inside here in exponential form. And so if we do that, watch, z is equal to ln, put square bracket, 5 e to the j theta, but theta is minus pi by 4. Like this. Now, if you look carefully, this is like ln of a times b. So this becomes ln 5 plus ln of e to the minus j pi by 4, which is ln 5, ln of e to the something. Remember, ln of e to the something is that something, which is minus j pi by 4. So that is what z is equal to. So if you look very carefully, we have now written this original number in rectangular form, where a is ln 5 and b is minus pi by 4. Pretty straightforward, nothing difficult there. All right, so remind yourself, we used at this point, we use ln of a times b, same as ln of a plus ln of b. That's pretty straightforward. Think about it, let it play around in your mind as well. Bang, and it becomes crystal clear. Okay, solve for x. Why do we have to always solve for x? Well, let's have a look here. Quadratic in x. So it tells me straight away, use a quadratic formula. X is minus b. Be careful, minus b is minus j, so it becomes plus j, plus or minus square root. I'm going to write this down as minus j squared, which is minus, well, is b squared minus 4 AC, AC, all over 2a. Now watch what's happening here. So minus b, that becomes j plus or minus. Be very careful here. Minus 1 squared is plus, but j times j, that becomes minus 1. Minus 4 times 2, that's going to be, this is so beautiful. That's minus 8 all over 4. So this becomes j plus or minus, watch, root of minus 9 all over 4. But what's the square root of minus 9? So I'm just going to squeeze it up here in this mangoish color. Beautiful. So x becomes j plus or minus square root of minus 9. Not 3, plus or minus j3 all over 4. And so we got two roots there. The plus root will give me, oh, this is really beautiful. J plus j3 becomes j4 over 4 becomes j, or j minus root j3 becomes minus j2 over 4 becomes minus j over 2. So that's my claim. I have two roots. If I substitute in there, let's just try the first one, j. Does it work? X squared, j times j is minus 1. That becomes minus 2. Then it's j times j is minus 1 and times minus 1 becomes plus 1 and 1, 2. 2 minus 2 is 0. Works beautifully. And there we go, guys. I hope you enjoyed this. A very quick run through 10 questions. Not really challenging, but picking out some crucial conceptual type points. Please go through it, review it. Just don't look at the solution and say, I can do that, or I would have done that. No, do it by yourself and then mark your work. And you will be ready for these questions. That is going to be really awesome. So take care, enjoy, stay safe, and remain calm.